Unit 1, Warehouse Management. Well, now we're going to talk about the classification of the warehouses. The first one is going to be according to the degree of atmospheric protection they need the materials required. We have in this case two kinds of warehouses, the warehouses that are covered or the open or outdoor stores. To start with the warehouse covered, we talk about the ones that have a building that it's made with bricks, canvas, or metal panels. The idea is that they offer complete protection to the materials that are stored there and also allow even the change of conditions, for example, temperature, humidity, or whatever inside the warehouse. In the other side, we have the open or outdoor stores. They are usually delimited by fences or markings, and they don't really have physical buildings. Uh, we store here the products that do not deteriorate or degrade with atmospheric effects or conditions, like, for example, new vehicles, new cars. In some cases, you can use some plastics or shrink wrap or something, a system that may be anti-corrosive to help prevent deterioration. Another classification we have is depending of the type of material that is stored. For example, the raw material warehouse, they are usually located near the production hall, near the production lines, or the site where the materials will be used to be transformed. Other one could be the warehouse of intermediate product that are semi-elaborated, semi-manufactured. Uh, they are generally located inside the manufacturing plant, inside the manufacturing line, because its mission is to act as a buffer between the different stages of obtaining a product. It is assumed that these materials have minimum waiting times for the use. They have it ready to use. The next one we have is the finished good warehouses, that they are exclusive for the finished product. And the function is the regulator. It's like an intermediate between the company, the warehouse, and the transit for the customer. Okay, it's very expensive to keep a finished good warehouse. So because the idea for any company is to keep the turnover rate as high as possible. Then we also have the spare parts warehouse that it's aimed for storing maintenance needs, all the tooling that they need to repair or to fix or to clean, right? And finally, we will also have the auxiliary materials warehouse that is dedicated to auxiliary materials used in production. Well, there is another kind of warehouse that it's not in the literature because it's not very common, but it depends on where you are working for. For example, I was working for an electronic company which used to have like a safety box for special products because in electronic industry there are a lot of materials, of raw materials that contain gold and silver and other precious metals. So they had to be in a special warehouse inside the general warehouse of raw materials, and they have to be locked. Okay, you needed a key and special access to enter this because this way you avoid that this material is stolen. The next classification we have is according to its function of distribution logistics. Warehouses of plant or central warehouse. They are the ones that are located as close as possible to the manufacturing center in order to reduce the cost of handling and transport from the output of production to the point of storage. Its main mission is to control the operation as a holder of the main stock and, in case necessary, supply regional warehouses. And in some cases, they act as regional in the area of influence where they are located. The next one are the regional warehouses that should be located as close as possible to the point of the greatest consumption in the region or area of influence, bearing in mind that this area of influence should be not wider than the distribution of a day. Its fundamental mission is to distribute merchandise of their wholesale or retail customers of a certain area. These warehouses must be prepared to receive large trucks from the manufacturing plants or suppliers and likewise be prepared for distribution in smaller trucks of capillary distribution. It will be of importance in this type of the area of preparation of orders. It's like, for example, Coca-Cola. they have like a kind of regional warehouse in the exit from Aguascalientes to Mexico. From there, they can distribute to all Aguascalientes and some parts of Jalisco. The next one is the warehouse platform. They are similar philosophy to the regional warehouse, but they have smaller dimensions because they use techniques such as cross-docking, that is a warehousing strategy of moving goods directly from the receiving dock to the shipping dock, reducing the handling and storage. An example of this is Walmart. They use this kind of example. Okay. They also use tense flow, or what we call just in time. In some companies, we also call it just in time. In Mexico, we call it that way because it's done when the producer has almost no stock and the production corresponds exactly to the customer's orders and is directly delivered to the customer and in the exact moment that it's needed. Okay, and also we have the shock stocks decreasing the global stock. The decision to create these stores will depend on this distribution design. Okay, the idea with the platform is to minimize stocks and increase the level of customer service. Finally, we have the temporary warehouses or deposits. They are intended to cover the peaks of demand that need to be served with an overstock. Usually, they are warehouses of temporary hiring, and it's necessary to have always in account that in case of having them, we must think well the merchandise we will deposit in them, taking care of, that this one is of direct service to the client or the regional warehouses, and never to return to the main warehouse. In fact, Jatco used this kind of warehouse just in front of the UTR. I don't know if you have seen the company Bantec Logistic. It's crossing the street behind the school. Behind there's another school in front of the UTR, and behind we can see Bantec Logistics. They are offering this kind of service to Jatco. Let's now talk about goods management. I'm going to put you a very simple example. How do I have to store any kind of materials? I'm not talking about a warehouse. I'm talking about your house. Do you store toxic substances, for example, cleaning material, next to food? Of course not. If you have something that is flammable, do you store it next to the stove? Of course not, because it may cause an accident. Okay, so when we are talking about the materials management, the goods management, we need to make sure that everything is in its place. Okay, and also, the selection of materials for product design is a challenging task because most of the essential raw materials that we use are infinite resources. Materials such as chrome, cobalt, diamonds, gold, iron, manganese, nickel, platinum, silicon, silver, titanium, water, crude oil, and natural gas are crucial for human life. And some of them are still abundant, but others are not. They will all one day become rare if they cannot be reused and recycled. So the use of recycled materials helps reduce environmental damage. The mining of materials such as tantalite, coltan, cassiterite, tin, gold, and wolframite tungsten in the Democratic Republic of Congo and some other adjoining countries is known to be used to finance conflicts. That's why they are called conflict minerals. Similarly, in diamond supply chains, there are conflict diamonds, or also called blood diamonds. In fact, there is a movie about it. Materials such as arsenic, mercury, lead, and phthalates are used for making electronic devices. And they are now being phased out by many manufacturers because they are hazardous to human beings and the environment during the production or during the disposal processes. Manufacturing technologies used to process different types of raw materials may consume large amounts of water and energy, and also produce large amounts of air, liquid, or solid emissions. Somehow, the selection of materials depend on the available manufacturing technologies. In various industries, managers ought to know that the applications of some substances help to meet product specifications, but they are also hazardous. There are many types of hazardous substances. like, for example, explosives, flammables, oxidizing agents and peroxide, toxin substances, substances causing diseases, radioactive substances, mutant causing substances, also called mutagens, corrosive substances, irritating substances, and other substances that could be chemical or otherwise, but they may cause injury to human beings, animals, plants, properties, or environments. Well, we have already talked about hazardous materials, but these are some examples of them. If you see this table, you can see in the first column the materials, the second the common usage, and in the last column you can find the environmental and social impacts. For example, something that is very, very common is the arsenic, right? It is used as an alloy in lead shot and electrical circuits. It's also used as a pesticide and as a preservative of wood. It is also used in the microchip industry and copper in production industry. However, it is highly toxic and it's also carcinogenic. Okay, it may cause cancer. People who work with pesticide and wood preservatives can be exposed to arsenic. This can also cause infertility, miscarriages, skin problems, and brain damage. Okay, this is the second. This is the second part of the table. As you can see, we can also see here the lead. You know what the lead is, I guess. It's used in the production of batteries, ammunition, paints, metal products such as solder and pipes, and devices to shield X-rays. But the danger is that if it's ingested or inhaled, can harm the nervous systems, kidneys, and also the reproductive system. In the past, lead was used for painting the cribs, it was really toxic for babies. Nowadays, it's forbidden. The basic function of a warehouse is to store goods, of course. What happened there? They receive deliveries for upstream suppliers, do any necessary checking and sorting, they store the materials under they are needed, and then they arrange delivery to downstream customers. In this graphic, we can see a basic layout of a warehouse where you have the arrival base, the storage area, the systems and control, of course, in the middle, and the departure base. We already have an idea of what are the warehouse managers doing, right? But some of the activities that are performed, this is not a limitative of the activities, but some examples are receiving goods, identifying goods and matching them to the orders to find their intended use, unloading the materials from the vehicles, and in some cases they have to do some checking in quantity, quality, and conditions. They usually label the materials with barcodes or other codes so that they can be identified. They sort goods, they move goods to bulk storage area. They hold them in stock until they are needed. When it's necessary, they move materials from the bulk storage to a smaller picking store. Also, they have to pick materials from the store to meet orders, move the materials to marshalling area, assembling materials into orders, packing and unpackaging when it's necessary, as well as loading delivery vehicles and dispatching the orders once that the materials are transformed into final goods, and also controlling all communications and related systems such as inventory control and keeping informed the finance area. Let's talk about materials handling. A lot of the work in a warehouse moves material from one location to another. Everything has to be taken from the delivery vehicles, moved around the warehouse, often several times, and eventually put onto departing vehicles. The activities involved form part of materials handling. What is materials handling? It's concerned with the movement of materials for short distances, generally within a warehouse or between storage and areas and transport. Every time an item is moved, it costs money, takes time, and gives an opportunity for damage or mistake. Efficient warehouses reduce the amount of movements to a minimum and make the necessary movements as efficient as possible. Some objectives of materials handle may include moving materials around the warehouse as is required, moving materials quickly, reducing the number and length of movements, Also, increasing storage density by reducing the amount of wasted space, reducing cost by using efficient operations, and of course, making few mistakes with efficient material management systems. These aims rely to a large extent on the choice of handling equipment. This can affect the speed of movement, type of materials that can be moved, cost, layout, number of people employed, and so on. In some warehouses, most of the materials handling is done by hand, with little equipment except perhaps for trolleys and baskets. Other warehouses have forklift trucks and cranes for moving heavy items. This suggests two levels of automation, manual and mechanized. There is a third level that is automated warehouses, where all the materials handling is managed by a central computer. These three levels of technology give warehouses completely different characteristics. Manual warehouses is probably the easiest arrangement to imagine, and is still one of the most common. Items are stored on shelves or in bins. People go around and pick the items from the shelves and put them into some sort of container for movement, like a supermarket trolley. There may be some aids like hand trucks for moving pallets or carousel to bring materials to pickers, but essentially people control all aspects of movement. You can get an idea of these operations by looking around a supermarket, which is very similar to a manual warehouse. Manual warehouses only work if the items are small and light enough to lift. Shelves must be low enough for them to reach and close together to reduce the distance walk. Materials are stored on shelves or in bins that are no higher than about 2 meters. The warehouse must be heated, lit, and allow people to work comfortably. The difference with the mechanized warehouses is that they replace some of the muscle power of manual warehouses by machines. Typical examples of mechanized equipment are reach trucks, which are usually electrically powered and move pallets and similar loads up to storage locations. A driver controls the truck, which can raise loads vertically to a considerable height. These trucks are quite small, slow, and with limited facilities, but they work well in confined spaces. Organ picking machines are a variation on reach trucks, where the driver is lifted with the materials to pick or deliver at high locations. Forklift trucks come in many different versions and are the standard means of moving pallets and equivalent loads for short distances. They are very maneuverable, flexible, and can be adapted for many jobs. On the other hand, they need space to work and they are fairly expensive to use. Cranes, which describe a family of vehicles used to lift materials. Tow lines, which are continuous cables that can move trailers around a fixed part, rather like ski lifts. And conveyors, which are used to move large quantities of goods along fixed paths. You can see many examples of conveyor belts moving material that range from iron ore to leathers. An alternative uses roller conveyors, tractors, or trains, which are the power units that pull loads that keep being put onto a trailer unit. The tractor delivers trailers to the place needed, rather like small articulated trucks or tugs and barks. Carousels, which are basically a series of pins going round a fixed track. At some point on the journey, items are put into a bin and the bins are emptied when they pass another chute or collection point. These warehouses can store heavier goods and may be much bigger. Some equipments need wide aisle to maneuver, but racking can be higher, typically up to 12 meters with a forklift truck and higher with cranes or height-reach equipment. Materials in these larger warehouses will probably not be put straight on shelves, but are likely to be in unit-sided loads. These are simply standard-sized packages or containers that are used for all movements. The idea is that the standard packages can be moved much more easily than a set of different sizes and shapes. The most common format, which we already have mentioned, is using pallets. These are wooden carriers that involve the standard measurement is 1.2 meters by 1 uh, back to the 60s. A survey found that forklifts were far the most widely used equipment for moving materials from warehouses. It's used in 90% of the companies. Other widely used equipment included various manual trucks, conveyors, and man-board trucks, horizontal carousels, stacker cranes, and some vertical carousels. The key point about mechanized systems is that they are still under the control of an operator. Someone actually drives a forklift or controls the movement along a tow line, but the next alternative is to pass the control of movements to a computer. in most of the companies, of the big companies that you will see in Mexico, you will find this kind of warehouses. However, there are some more technological warehouses nowadays. I haven't seen it in live, but they exist. That are the automated warehouses. Okay, this operating this is a very expensive one. Okay, but also helps to reduce some cost of operation. Because you are using automation, instead of paying people, you have to invest in equipment. Okay, but the needs of investment in this kind of equipment is really high, and it's only really worthwhile for very big stores that move large amounts of materials. That's why you won't see it very easily in all the companies. Automated warehouses work in the usual way, but including the following components, like the storage areas that can be accessed by automatic equipment. These often use narrow aisles up to, say, 40 meters tall to get a high density of materials and minimize the distance moved. Also, the equipment to move materials around the warehouse that are usually automated guide vehicles, also called AGVs, which use guide wires in the floor, but might include conveyors, tractors, or a range of other moving equipment. Also, we have equipment to automatically pick materials and put them into the storage, including high-speed stacker cranes that can reach any point in the narrow aisles very quickly, and equipment to transfer materials between the different types of equipment. These automatic loaders and unloaders may include industrial robots. A warehouse management system to record material locations and control all the movements. There can be considerable benefits to automation because, for example, you can find that errors are reduced, you can improve your records of inventory, increase your productivity, reduce paperwork, improve space utilization, lower stocks, better control of movements, support for better customer service, and obviously that you don't have people working in storage areas. So you don't really need heat, light, and you also reduce the possibility of human accidents. Let's talk about inventory management. Inventory management is more than inventory control. In fact, it's a principle composed by three-step processes. First, developing an inventory policy that is related to the targeted customer service levels that we are expecting. Second one is planning inventory based on demand patterns and production schedules. And third one is controlling inventory through systematic reviews, adjustments, transfers, cycle counting, etc. Well, remember, inventory is an asset and it's held for current and future use for sale or distribution. It represents an underutilized resource, so it can end up being a financial burden for the company. Despite the risks associated with inventory, many companies want to keep inventory to meet anticipated customer demand and for not losing any sale opportunity. Of course, without inventory, it's difficult to make products available for customers when they need it. So inventory is considered a viable alternative for future production and procurement. However, inventory can also be problematic when it exceeds actual customer demand or it becomes obsolete. What is the difference between an excess and obsolete inventory? Well, the excess is when the amount of inventory on hand exceeds 12 months projected customer demand, and it's obsolete when it has no forecast usage and little or no usage in the last 6 months. Okay, this is a wasting. This is one of the 7 wastes. You can find out about the 7 wastes in quality, because a lot of companies will sell it with a discounted price in the best of the cases, but also it's costing the storage space, and in some cases you have already paid some taxes because of this inventory. Considering the two contrasting phases of inventory, the careful policies, planning, and control are necessary to keep the right amount of inventory at the right place, essential for customer service, so that you can keep the cost of maintaining inventory at minimum. Let's do an example. Imagine you sell every month 1,000 beers. Your real cost per beer is $1, but you sell it into dollars. So your monthly sales is $2,000 investing $1,000. Considering that you already know that in 2021 you will sell 12,000 beers, what option is better for you and why? First one, buy 20,000 beers in January. Second option, buy 6,000 beers in January and 6,000 beers in July, or buy 1,000 beers every month. Think about it. Now we have the solution. If you buy 12,000 beers in January, you will be investing $12,000 and your sale is $24,000 in a year, so you will make at the end of the year $12,000, right? 1,000 per month. The second option, if you buy 6,000 beers in January and 6,000 beers in July, you will be investing $6,000 in January, okay? You will be selling 1,000 every month, yes? So you will make $6,000 at the end of June, right? But you also recovered your $6,000 that you invested initially, so you reinvest them in July, and then everything is going to be like an earning, right? So you will be making in the second part of the year $12,000 because all the sales will be totally earning. So if you invest $6,000, you will be making $18,000. But what happens if you buy 1,000 beers every month? You will be investing 1,000 in January and you will be selling 2,000, so you will recover 1,000 and you will earn 1,000. So you reinvest the same $1,000 in February and you will make another $1,000, right? But since you are reinvesting, in fact, in February you are making $2,000, okay? And in March you are reinvesting the first $1,000 and you are making other $2,000. That's why your total earning after the year will be $23,000. Well, now we will talk about the functions of inventory. Despite the pitfalls of holding inventory, there are several reasons why many organizations keep it. It depends on the functions of the inventory, like, for example, buffer inventory, that it's an extra cushion that is kept over an extended period to prepare for unexpected demand surge and subsequently prevent potential stockouts. This kind of inventory is often needed to reduce the risk of shutting down the production line and distribution disruptions. The buffer inventory is also called safety stock. We also have the lot size inventory, that is inventory accumulated as a result of overpurchasing and overproduction to take advantage of economies of scale. To elaborate, many organizations purchase some products in volume to exploit quantity, volume discount, or freight discounts opportunities. Also, a company can reduce per unit setup cost by mass producing goods at once. This kind of inventory is also called cycle stock. The next one is the anticipation inventory. This inventory built up in anticipation of future estimated demand, price increases, promotional campaigns, seasonal fluctuations, labor strikes, or plant shutdowns. This kind of inventory helps maintain level production or distribution that prevents overtime or idle time in the future. The seasonal inventory that is kept for the upcoming Thanksgiving holiday or Christmas season is a good example of anticipation inventory. Another example includes a speculative inventory that is kept to protect the company from future price inflations or product shortages. The pipeline or in-transit inventory exists due to transportation time lag. In other words, products in transit can be considered to be inventory because products that were pre-ordered but have not reached warehouses, distribution centers, or retail stores are still not available for customers. This kind of inventory can be reduced by using a faster mode of transportation. And the last one is the decoupling inventory. It makes every stage of the supply chain independent of any unexpected supply chain disruptions. For example, machine breakdowns during the manufacturing stage will shut down the production process, which can subsequently create either shortages of work in process inventories at the next production stage or product shortages at the following distribution stage. Therefore, the coupling inventory kept between various stages of the supply chain that will allow paced production and distribution without interruptions. Let's talk about the types of inventory. In terms of production transformation processes, inventory can take a variety of forms. These forms are generally classified into raw materials, parts and components, work in process or WIP, finished goods and supplies. Okay, what is the raw material? The raw materials are virgin physical resources or items that are purchased from external organizations or that are extracted from natural sources, such as mines to be used for making parts or components or products. Some examples may include steel or iron for the nuts and bolts, plastic for the automobile dashboard, glass for windows, wheat for bread, aluminum for a bucket, rubber for a ties, etc., etc. Parts and components are the major ingredients that will make up a finished product and make it function properly. Examples include battery and engine for the automobile, a hard drive for a PC, a dust bag for a vacuum cleaner, a knob for a desk drawer, etc. The working process, or WIP, refers to the items that are still in the manufacturing process and are awaiting to be processed within the supply chain. It often plays the role of the coupling inventory that we just discussed in previous slide. Then we have the finished goods that are completed items that are ready for sale or distribution. In other words, are the ones that do not require any more of the transformation process. It's ready to ship. And finally, we have the supplies that are items that need to go engage in the production process, but do not comprise the finished product. What is that? Some materials for maintenance, for example, for repairing, for operating, that is called MRO, maintenance, repair, operating, supplies, as well as pencils, pens, paper needed for drawing the blueprint of a newly designed automobile, light bulbs that allow the worker to get engaged in the process of producing an automobile engine, or inside a dark manufacturing plant. Okay, it's everything that we need to produce, but it's not necessarily part of the finished good. With the growing need for customization of products, a lot of manufacturers have diversified their product lines. For instance, milk products can be categorized into several different stock keeping units, or SKUs, such as whole milk, 2% low-fat milk, zero-fat milk, lactose-free milk, chocolate-flavored milk, etc., etc. Such product proliferation can overwhelm the task of managing all SKUs with equal attention. So the priorities should be set to handle inventories. One of the systematic ways of classifying inventories with respect to their priorities includes a classic Pareto principle, where approximately 10 to 20% of the inventory accounts for 60 or even 80% of the total inventory value, or 80% of the sales volume is typically accounted by 20% of the products for customers. The most popular inventory classification schemes include critical value analysis and ABC inventory analysis. The first scheme we will talk about is the critical value analysis that is frequently used by a military organization. This consists in subjectively classifying inventory items by assigning point values for 3 to 5 categories, more or less. In this table below, you can see that we are talking about 4 priorities: top, high, medium, and low, right? The top priority items should not have any stock out. They are very critical. In the case, again, from military, it's, for example, ammunitions and rifles, because a shortage can jeopardize soldiers' life. So that's why it's critical. Then we have high priority that are essential, but, well, in some cases we can have some stock outs, like, for example, military vehicles and armored vehicles, whose shortages can undermine the soldiers' fighting capability. Okay, they reduce their capability, but it's not life or death like the munitions and rifles. The third one would be the medium priority that are necessary Okay, but occasionally we can have some shortages. Okay, like military tents and shovels whose shortages could not create life-threatening situations for soldiers, but are requesting further comfort. And the low priority, well, it's desirable that we don't have any stockouts, but if we do, there is no big issue. Like, for example, the uniforms, the shirts, the underwear are not really essential. They are not the most important thing for a combat. The ABC inventory analysis is more used in the companies, and it classifies items or SKUs into three categories: A, B, or C items according to the total annual dollar dash. Okay, some of the criteria that we have to use to classify ABC would be the annual dollar volume of transactions for an item, the unit cost or the price, the scarcity of materials used in producing an item, also the availability of resources, the manpower, the facilities that you need to produce an item, also the lead time, the storage requirements, for example, if they need a refrigeration or something special, special handling. Also, if we have pilferage or shrinkage risk or shelf life, if they have like an expiration date, for example. Also, the cost of running out of the stock and engineering design volatility. Here we can see an illustration of the ABC classification scheme depending on the question, right? And depending on the annual source, the unit cost, the lead time, and the shelf life. In the second example, we can see that this table is summarizing the degree of control and planning associated with the ABC inventory classification scheme. This third example provides specific guidelines for managing different types of inventories. In this last example, we can see that because of a shortage or unavailability of higher dollar usage or fast-moving items, we can have a greater adverse impact on the customer service level. Different customer service strategies should be developed then according to the ABC classification that we see. Cycle counting. Missing or unaccounted inventory can be costly because it increases time looking for items, it delays or fails to fulfill customers' orders, or it lengthens production time. It raises expediting cost and increases inventory carrying cost. To prevent missing or unaccounted inventory, many companies practice cycle counting, which generally refers to counting inventory physically on a cyclical schedule to check the inventory accuracy. Thus, cycle counting involves comparing physical quantity on hand with the quantity on record and identifying causes that contribute to count variance. Such causes may include multiple inventory locations, off-site inventory locations, unrecorded inventory transactions, poor inventory classifications, picking errors, misplacement of hour, for example, midnight, requisitions, untrained or careless counters, missing documents, too many expedited shipments, and unclear tolerance limits. Also, the two primary methods for tracking count variances are on-hand tracking and transaction tracking. The on-hand tracking is the most commonly used method, and it gives you a snapshot of what your inventory accuracy is at that specific point in time. It is helpful in projecting the impact your variances might have on subsequent operations. However, cannot pinpoint process problems because it relies heavily on current on-hand balances. For example, if on a given date you count a certain part and then discover a shortage of 30 units out of an on-hand balance of 100, the inventory occurrence rate is supposed to be 70%. However, if you did not count this item until the following day and the additional 2,900 units were received prior to the next cycle count, your accuracy rate would be 99%, even though you are still missing those 30 units. The transactional tracking compares the variance amount to the amount consumed during the count period, and is therefore far more useful in determining process problems than on-hand tracking. Unfortunately, this method can be more difficult to implement than an on-hand tracking. Cycle counting can be more efficient when counting a certain small percentage of the total number of items daily, with prescribed frequency for each item and assigning responsibility for reporting inventory transactions for specific employees. If accurate, inventory records can be maintained over several consecutive years. The company may be able to eliminate periodic physical inventory counts, and the key issues of cycle counting include the following. First, what to count. For example, items or items with high preference risk. How often to count it? Weekly count is generally desired. However, at least every 12 or 13 weeks is appropriate. If you see, it's an estimate of 3 months. Corporations, in running their daily operations, require the acquisitions of goods and services, and this needs to be accomplished with efficiency, cost effectiveness, and meeting company objectives within set constraints. In this case, purchasing management is either a part-time or full-time corporate initiative to accomplish this successfully. As companies mature, this initiative becomes its own profession and fifth point within the corporation. In the thousands of corporations that landscape our economy, purchasing is an executive position, department, or cost or profit center, and it's a critical function of corporate governance. Why do you think it's so important, purchasing management? Because more or less 80% of the expenses of the company go through our purchasing department. A well-known statement of the objectives of purchasing is to acquire the right quality of material at the right time, in the right quantity, from the right source at the right price. This somehow guide statement is criticized by some as being kind of superficial and simplistic. Okay, it's valid because this definition provides a practical starting point of discussion. But purchasing is more than that. Purchasing is also supply the organization with a flow of materials and services to meet their needs, to ensure continuity of supply, maintaining effective relationships with existing sources, and developing other sources of supplies, either as alternatives or to meet emerging or planned needs. Also, it's to buy efficient and wisely, obtaining by an ethical means, but the best valued by every pound or every dollar spent. To maintain sound cooperative relationships with other departments, providing information and advice as necessary to ensure the effective operation of the organization as a whole. And also develop staff, procedures, policies, and organizations to ensure the achievement of the objectives, okay? Also, there are some more specific objectives like select the best suppliers in the market, help to generate the effective development of new products, protect the company's cost structure, savings, all the money. Remember, 80% of the money in a company pass through purchasing. Also, we need to maintain the correct quality value balance, monitor supply market trends, what we call market intelligence, and to negotiate effectively in order to work with suppliers who will seek mutual benefit through economical and superior performance. And finally, to adopt environmentally responsible supply management. We can summarize the purchasing cycle in the main stages. First, the recognition of a need. Specification then, the make or buy decision, the source identification, the source selection, the contracts, the contract management, the receipt and possible inspection, the payment, and the fulfillment of the need. The idea of the purchasing cycle is often employed to indicate the main activities in which purchasing might be involved. The activities included in the cycle do not include all of those that a purchasing staff might be involved with. There are many activities such as, for example, negotiation, vendor rating, and source development that are not specifically included. It will be noticed that the early and late stages in the cycle may not necessarily involve specialist purchasing staff, the core purchasing contribution to the cycle being the items included in the central part of the list. A limitation of the cycle concept is that it does not recognize the strategic contribution made by the mother purchasing. Now let's talk about the economic order quantity, that it's the Harris-Wilson model. I'm going to mention it this because it's part of the program, but honestly, it's very difficult to apply because this is a popular approach for calculating the quantity to order. Okay, we use a formula called the EOQ formula that determines the least cost quantity at which acquisition cost equals to the cost of possession. If you remember, we did an exercise with beers in previous slides, uh, trying to calculate which is the best amount to buy to spend the less money possible and make the more money, right? Well, this formula is very simple. The order quantity in units is going to be the square root of two times the annual such in units per order in costing dollars per order between annual carrying cost percentage per the cost per unit in dollars, right? Why I'm not going deeper in this model? Because this model assumes that the ordering cost is constant and it does not depend on the quantity ordered. Okay, so unfortunately, if we work it in theory, it works, but in practical situation, honestly, it's not really true. By in the other hand, nowadays we also have some ERP, some programs, some softwares that are calculating this by themselves. So don't worry, maybe you don't remember how to calculate the square root, but it's not going to be a problem, and it's not going to be in a test or in a survey for this class, because it doesn't make any sense to work it when it's not really working. Well, as I commented you, for the evaluation of this course, we're gonna do 4 activities with 15 points each one, okay? The first one will be talking to your team, okay? You have to form teams from 7 to 8 members, and you will have to select a company. It doesn't matter if it's a small company, okay? But the idea is that you work there or you have access to information of the company, okay? So that we can do it as real as possible. But the most important thing is that this company has to keep materials stored, okay? They need to have a warehouse, otherwise it won't work. And then we will have to develop. First, of course, you have to include a cover with the team members' names, and of course the subject, my name, and everything. Then the index, okay, where you will list everything that is part of this work. The third part, it's going to be an introduction that it's worth 2 points, okay? In this section, you have to explain what is this work about. Don't look for concepts in the website. You have to explain. Imagine that you are explaining to a friend of yours who has no idea what we're talking about. What is this work about? Then the next point is going to be warehouse classification applicable. If you remember and see 1.1, you saw that there were several classifications. We will have to see which is the most applicable for this company that you're working for. This is worth 1 point. Then you will have to draw the current layout that the company has, but also you will have to propose a layout. Okay, remember, we have to consider the kind of materials that are stored, including hazardous. Okay, and it's gonna work 2 points. Then you have to describe correct inventory control and materials handling. You have to go back to 1.3 and subteams, and you have to explain how are they having the inventory control and material handling, or if they are not, and what would you suggest in case they don't have anything, or in case that you detect any opportunity to improve. The next, this is going to work 2 points, and then we have to do and develop the functions and types of inventory applicable. Same, you have to go back to 1.4 and subteams to verify which is the types of inventory that we will consider it's applicable for this company. Then the next, this is going to work 1 point, and then the next step is going to be from the 4 ABC classifications examples that I provided you in 1.4.3.2, you have to describe which one is the best, the one that will work better for the company. And of course, you have to justify your response. This is worth 2 points. Then you have to discuss and describe if cycle counting should be executed or not, and why, and which are the conditions. You will have to explain all the rules for performing a cycle counting in case that it's applicable. And then you have to describe if the company has a purchasing management process, or even if they have a department, and how it works. You have to do a description, how they are handling their purchasing. This is 1 point word. And finally, you will have to develop your individual conclusions. where you explain what you learned from this work. Okay, this is individually, you have to do minimum half a page, and it's worth 3 points. Okay, depending on the responses, if you see, even when you are working all together, the last 3 points will be applicable depending on your own responses.